All right, so today we're diving deep into the world of those large language models that everyone's talking about.
LLMs.
Yeah, LLMs, but
Like ChatGPT.
exactly like ChatGPT, but we're going beyond the hype.
Beyond the hype.
Forget asking to write a poem. We want to know.
We're cracking open the hood.
Yeah, what makes these things really tick?
Yeah, how do they actually work?
What are they good at? What are they bad at? And
Where does the research go from here?
exactly. And our guide for this deep dive is AI expert Professor Michael Littman.
And this is a really insightful conversation.
Oh yeah, he dropped some serious knowledge bombs.
He really did. This was recorded at ICML,
The International Conference on Machine Learning.
which for people who don't know,
If you're in AI,
yeah,
that's the place to be.
that's the Super Bowl.
Exactly.
And one of the things that Professor Littman said that really struck me was how he described LLMs as essentially statistical models of databases.
Okay, I'm already lost.
Okay.
Break that down for me. What does that even mean?
So it sounds simple, but that analogy is surprisingly revealing.
Because it means that these LLMs are incredibly good at recognizing patterns in massive data sets, but they don't truly understand the information.
So they don't actually get it.
They don't get it. They're not sentient.
Right.
It's like, imagine a gigantic library. An LLM is someone who's memorized the location of every book, every sentence, every word.
But they've never actually read a single one.
They haven't read a single one. They just know where it is.
Wow, okay. So they can find the information, but they don't really grasp like the meaning behind it.
Exactly. And because of that reliance on pattern recognition rather than true understanding.
This is where things get a little weird, right?
This is where things get a little weird
Okay.
because it leads to some interesting quirks. Professor Littman shared an anecdote about asking an LLM to sort a list of words alphabetically.
Oh yeah, this is a good one.
Ascending order aced it.
Okay.
Descending order.
Wait, it messed that up.
It struggled.
Really? How is that even possible? Because it highlights just how much these models rely on the frequency of information in the data they're trained on.
So it's not about actually understanding the alphabet.
No.
It's about recognizing a familiar pattern.
Exactly. And that's a little unsettling, right?
It's like realizing that supercomputer you thought was sentient
Right.
is basically just really good at flashcards.
Just really good at flashcards. And it's precisely this reliance on patterns that leads to those infamous LLM hallucinations.
Everyone's seen them online.
The confident wrong answers.
Yes, like where did they even get that information?
Well, that's the thing. They kind of make it up.
Right.
It's plausible sounding, but it's nonsense.
Right, and that's because they don't actually understand what they're saying.
They don't. And this is a huge area of research right now.
So what are people doing about it?
How do you make an LLM know what it doesn't know?
Right, because I'd feel a lot better if it at least knew when it was making stuff up.
Exactly. So a lot of the current research is focusing on how to make LLMs better at knowing what they don't know, building in a healthy dose of uncertainty.
Uncertainty.
And there are two key types of uncertainty that researchers are working with.
All right, hit me with it. What kinds of uncertainty are we talking about?
So the first is called aleatoric uncertainty, and it's basically uncertainty about word choices.
Okay, so like when you're writing and you can't decide between two synonyms.
Exactly. Thus or therefore.
Right, exactly.
The AI equivalent of that debate.
Okay, got it.
The second type, and this is a big one, is epistemic uncertainty.
Okay.
This is the uncertainty about whether they even have the knowledge to answer a question in the first place.
Ah, so that's where the hallucinations come in.
That's where the hallucinations come in. Instead of saying, I don't know,
Right.
they try to wing it
And make stuff up.
and make stuff up.
Yeah.
Imagine if instead of confidently asserting something incorrect, an LLM could say, I'm not sure, but based on what I do know, here are 3 possibilities.
That would be amazing.
Right.
An AI that admits when it's out of its depth.
That's the dream. Okay, but even then, even if we get them to that point where they're not just making stuff up, are they ever going to be able to think logically like humans?
That is the million-dollar question, right? Because traditional AI was all about logic.
Yeah, that step-by-step reasoning.
Exactly, system 2 thinking. And LLMs, they haven't quite mastered that yet.
Right.
But what they do excel at is pattern recognition and contextual understanding.
Okay.
System 1 thinking.
So 2 very different approaches.
2 very different approaches,
Yeah.
and Professor Littman sees them as potentially complementary.
Yeah, this is where it gets really interesting.
Imagine an LLM that can tap into formal reasoning tools when needed, but also draw on its vast well of contextual knowledge.
So it's like having the best of both worlds.
The best of both worlds.
Mm.
So let's say an LLM is tasked with writing code.
Okay.
It could use its System 1 strengths to generate the code itself.
Okay.
But then it could call upon a separate formal reasoning engine to double-check its work for errors.
Like having a built-in debugger that operates on pure logic. That's amazing. It's a really fascinating area of research, but even with this combined approach, there's still the issue of knowledge itself.
Because if they're just these massive repositories of information,
Right.
how do we make sure that knowledge is actually organized in a way that makes sense?
Exactly. And this is where Professor Lippmann gets really passionate about knowledge graphs.
Knowledge graphs. What are those, and why are they so important in the context of LLMs?
So think of a knowledge graph, like a giant interconnected web of information.
Okay.
It's a structured representation of knowledge that's much easier to update and reason about.
So instead of just memorizing a bunch of random facts,
Right.
it's about understanding the relationships between those facts.
Exactly. It's like the difference between memorizing a dictionary and actually understanding the nuances of a language.
Okay, so how do we even begin to build these knowledge graphs?
Well, that's the really exciting thing. Research is exploring how LLMs can actually help build and utilize these knowledge graphs.
Oh, wow. So they could actually be used to create their own knowledge structure.
Exactly. Professor Lippmann shared a really thought-provoking example.
Okay. I'm intrigued. Lay it on me.
He asked us to imagine a future where scientific research wasn't locked away in static PDFs.
Okay.
Picture it constantly being fed into a dynamic knowledge graph that's updated with every new finding, every new insight.
Okay, so we're talking about a constantly evolving body of knowledge.
Constantly evolving, and LLMs would be the ones to make it happen.
So they'd be analyzing new research, extracting the key findings, and then updating the knowledge graph automatically.
Exactly. We're talking about a constantly evolving tool for scientists, for everyone, really.
Okay, whoa, that's a lot to process.
It's huge.
I'm already imagining the headlines, LLMs cure cancer.
Let's not get ahead of ourselves.
Okay.
But you can see the potential, right?
Oh, absolutely. The interconnectedness of all that information.
Right.
It could be incredibly powerful.
It really could.
But, as always, we have to remember that LLMs are still in their infancy. We're just starting to scratch the surface of what they might be capable of.
Right.
And there are still some pretty big challenges to overcome.
Huge challenges, like how do we make sure that these powerful technologies are developed responsibly?
That's a big one.
It is. And that's something that Professor Lippmann feels very strongly about. He's a huge proponent of something he calls open science.
Okay, so we're talking open source code, publicly available research.
Exactly. He believes that sharing research findings and even the underlying code for LLMs has been crucial for the rapid progress we've seen in the field.
Makes sense because it allows researchers to build on each other's work,
Right.
spot potential problems more quickly, avoid duplicating effort.
And in a field as complex and potentially impactful as AI, that kind of transparency and collaboration is essential.
It's like the difference between everyone trying to reinvent the wheel in isolation
Right.
versus working together to build something truly extraordinary.
And Professor Lippmann points out that this openness has fostered a real sense of community among AI researchers.
That's really encouraging to hear because, let's face it, the ethical considerations surrounding LLMs,
Right.
the potential for misuse, it can feel pretty daunting.
It's true. We're talking about technologies that could reshape entire industries.
Even societies.
Even societies. And these models, they don't exist in a vacuum.
Right.
They're trained on massive data sets that reflect all the complexities of the real world.
Which is why it's so important to have diverse voices and perspectives involved in the development and deployment of these systems.
Absolutely. It's something that researchers and policymakers are really grappling with right now.
Yeah. How do we make sure that these ethical considerations don't just become empty platitudes?
It's a big question, and I don't think anyone has a perfect answer yet.
Oh, sure.
But one thing is clear.
What's that?
These issues are too important to be left solely in the hands of the tech industry.
Right. This is something we all need to be thinking about.
Exactly. And that's why we're here today.
Here at The Deep Dive.
We want to empower you, our listeners, to be informed and engaged participants in this incredible journey into the future of intelligence.
Because the future of AI isn't something that's going to be decided for us.
Right.
It's something we're all actively shaping, whether we realize it or not.
And Professor Lippmann left us with a really thought-provoking question, something for all of us to consider as we delve deeper into this world.
Okay, you're going to leave us hanging on a cliffhanger.
I am.
What's the question?
He asked us to imagine a world where an LLM could access and synthesize information from any knowledge source in existence. Libraries, archives, scientific databases, the entire internet.
Okay.
Anything you can imagine.
Wow, that's a lot of information.
And his challenge to us was this: what would you ask?
What would I ask?
What questions would you want answered if you had that kind of knowledge at your fingertips?
Now, that is a good question, and one that I think we'll all be pondering for a while.
I suspect we will, but for now, let's take a quick break, and when we come back, we'll dive even deeper into the world of LLMs and explore some of the most fascinating research happening right now.
Sounds good.
Yeah.
I'm ready. Let's take a break.
So, we were talking about knowledge graphs.
Yeah.
And how important they could be for LLMs.
Right. Organizing all that information.
Exactly. And Professor Lippmann actually touched on some really cutting-edge research that's happening right now in the realm of knowledge representation.
Okay.
It's all about moving beyond those static knowledge graphs that we were talking about before towards something way more
so like dynamic,
directed.
All right. So what does a more dynamic knowledge graph even look like?
Yeah, that's a great question.
Is that even possible?
Well, it's definitely on the bleeding edge of AI research right now.
Okay.
But Professor Lippmann seems to think it's within reach.
Okay.
So imagine a knowledge graph that's not just updated with new information, but one that actually learns and adapts on its own.
Wow.
And
it's alive.
Kind of like how our understanding of the world evolves over time.
So instead of us just feeding it information, it starts to make its own connections.
Exactly.
Its own inferences based on what it already knows.
Exactly. And not just that.
Okay.
Professor Lippmann believes that LLMs could actually play a key role in creating these self-learning knowledge graphs.
Oh, wow.
He talked about the possibility of using LLMs to not just extract facts from text, but to actually understand the underlying concepts and relationships.
The way humans do.
Yes, exactly.
So we're talking about true AI insight here.
Yes.
Not just clever pattern recognition.
You're not just pattern recognition.
This is like next level stuff.
Exactly. He used a metaphor that I thought was really powerful.
Okay.
He said, imagine if we could train an LLM on the entire history of scientific discovery.
The entire history?
Not just the facts and figures, but the actual thought processes.
Okay.
The dead ends, the breakthroughs, everything.
Okay, now my mind is officially blown.
Right.
What could we achieve if we had access to that?
It's incredible.
That kind of knowledge, that lineage of human understanding.
That is the million-dollar question, isn't it?
It really is.
Professor Lippmann seems to think it could revolutionize scientific discovery, education, even artistic expression.
Really?
Imagine having an AI that could not only understand the history of a field, but could also generate hypotheses, connect seemingly disparate ideas, and even point us toward entirely new avenues of exploration.
It's like having an AI collaborator.
Yes.
Someone who can push us beyond the limits of our own thinking.
Exactly. And that, I think, is what makes this whole field so incredibly exciting.
It really is.
We're not just talking about building machines that can do things for us, but machines that can help us understand ourselves and the world around us in ways we never thought possible.
It's a lot to take in.
It is.
But it's incredibly inspiring.
It really is. And it's why Professor Lippmann is such a strong advocate for open science.
There's that open science again.
He believes that the more we can share our research, our code, our data, the faster we'll be able to unlock the true potential of these technologies.
Because when we work together, we can achieve so much more than we ever could alone.
And that brings us back to the question that Professor Lippmann left us with.
Okay.
What would you ask?
If I had access to all of that.
If you had access to a knowledge base that encompassed the sum total of human knowledge, what questions would you want answered?
It's such a simple question.
Right?
But it really makes you think.
It does.
What mysteries would I want to solve?
Yeah.
What problems would I want to tackle? It's like he's saying, we need to dream bigger, right? Like the only limit to knowledge is asking the right question.
And what's so amazing is thinking about the breakthroughs we could make.
I know, right?
If we could tap into that.
If we could really access all that.
It's mind-blowing.
It really is. And it's kind of empowering too, right?
Oh, absolutely.
Like, we're not just stuck with whatever information we happen to come across.
Yeah.
We can actively search for the answers we're looking for.
Exactly. We have the potential.
We really do.
To shape knowledge.
And that's a huge opportunity.
It is.
But it's also a huge responsibility.
It is. There's that word again.
I know you didn't think you'd get away without mentioning it.
Great responsibility.
You know, it's true, though.
It is.
And I think it's something Professor Lippmann really wanted us to think about.
Yeah.
Because as we build these incredible AI systems,
right,
we can't forget about the potential consequences.
Yeah, the unintended ones too.
It's like we're giving someone a toolbox, right?
Okay.
We can teach them how to use each tool safely, but ultimately it's up to them to decide what they're going to build with it.
And in this case, we're not building a birdhouse.
Definitely not.
We're talking about tools that could reshape society as we know it.
Exactly. So we need to be having these conversations now, thinking critically about the ethics involved, making sure these technologies are used for good.
100%. And it's not just on the AI researchers or the policymakers.
This is on all of us.
This is on everyone because the future of AI is being shaped right now.
It is.
By all of us.
So to all of you listening, what will you ask?
What will you do with this knowledge?
The future of knowledge is in your hands.
That's it for this deep dive.
Until next time, keep exploring, keep questioning, and keep diving deep.